We'll look at some basic examples of determining x and y intercepts of various functions. First of all, what are intercepts? So an x-intercept is a point where the graph touches the x-axis. Okay? Since, if you think about this, any point on the x-axis, since any point on the x-axis is an ordered pair that looks like some number, comma 0, right? Think about any ordered pair on the x-axis, the y value is 0. So since any point on the x-axis is an ordered pair that looks like a number, comma 0, we know that the y value of any x-intercept is 0. So keep that in mind. We'll do the same statement here about a y-intercept. So y-intercepts have an x value of 0, okay? And so let's actually determine these. So the conclusion here, to determine an x or y intercept from a function equation, we plug in 0 for y or x respectively. Okay? So we will use that fact to work some problems now. So let's do an example. So we have this function f of x equals 2x minus 5. I want to know the x and y intercepts of this function. Okay, so realize that this equation, this function equation, is the same as y equals 2x minus 5. That can be useful because it helps you see the y variable. So now if I want to go determine my x-intercepts, I know that y has to be 0. And this equation becomes 0 equals 2x minus 5. And now I can solve for x. So I want to make a note here. When determining an x-intercept, we should be solving for x, right? If you want to know the x, you better solve for x. That is another hint that we should plug in 0 for y. Because the mistake a lot of people make is when they want to find an x-intercept, they think, oh, I should plug in 0 for x. No, that's wrong. Don't plug in 0 for x. You need to know what x is. So you're going to plug in 0 for y so you can solve for x. All right, let's finish solving for x here. So we'll add 5 to both sides. So we get 5 equals 2x. Then we'll divide both sides by 2, and we'll get 5 halves equals x, or if you want to flip that around, x equals 5 halves. So the x-intercept has the x value of 5 halves and a y value of 0, as we already know, and we get the ordered pair 5 halves, comma 0. Okay? Now let's look at the y-intercept. Here we plug in 0 for x, so we can solve for y. So I get y equals 2 times 0 minus 5. 2 times 0 is 0. 0 minus 5 is negative 5. So the y-intercept is the ordered pair where y is negative 5 and x is 0. So here we determined the x and y intercepts of this function, and the key was to rethink the equation involving a y. Okay, you may have seen intercepts before, but maybe not with functions. So if you have a function, think of it as an equation with y, and then it's just like every other intercept problem you may have ever solved. Okay, here we have a bit more complex function, and I just asked for the y-intercept. So if I want the y-intercept, that means I'm going to plug in 0 for x. And so this equation, remember, is the same thing as y equals negative 3x squared minus 4x plus 2. So when I plug in 0 for x, I get y equals negative 3 times 0 squared minus 4 times 0 plus 2. Well, negative 3 times 0 is 0, minus 4 times 0 is 0, plus 2 is 2. So the y-intercept is the ordered pair 0, 2. Now, just a comment about why I did not find the x-intercept here. If I wanted to find the x-intercept, I would plug in 0 for y. And you would get the equation 0 equals negative 3x squared minus 4x plus 2. Now, I don't know what level you're at. If you're in one of my classes, you may or may not have seen how to solve this type of equation. So there are ways to solve this for x. You just have to know how, and that's not what this video is covering. This is called a quadratic function. So if you want to know how to solve it, you could go look up how to solve a quadratic function. I do have a video on that as well somewhere. You can do it by factoring, completing the square, or the quadratic formula, which may be the most popular. But anyway, you solve for x, and then you'll know the x-intercept, or maybe more than one x-intercept. That can happen sometimes as well. Okay? So for now, I just wanted to illustrate the y-intercept. We'll do one more example where I want the y-intercept of this function. And again, this is just like the equation y equals 3x minus 4 over 5x plus 3. And I will plug in 0 for my x's, since I want the y-intercept, and I'll have 3 times 0 minus 4 over 5 times 0 plus 3. 3 times 0 is 0, minus 4 is negative 4. 5 times 0 is 0, plus 3 is 3. And we get that y equals negative 4/3. So the y-intercept is the ordered pair where y is negative 4/3 and x is 0. We plugged in 0 for x. So there are some general basic problems dealing with intercepts.